Hi, good morning, and welcome to A-Level Physics Case Today session. Today, I will tell you about the course and the entry criteria for A-Level Physics and what you can do after the course and what topics we'll study throughout the course. So, it's me and Aditi Sood. I teach maths and physics here, and I have completed my PhD in 2016 from University of Sheffield. I have studied applications of mathematics in solar and stellar physics. And this is Chantel. She is head of curriculum, sixth form department. So A-level physics is a two-year course where we cover each topic of physics. Students develop knowledge and understanding of various concepts ranging from classical mechanics to modern physics. I'll just let you know about the classical mechanics. Classical mechanics is the branch of physics which deals with your Newtonian mechanics, your thermodynamics, your um, electromagnetism, whereas modern physics is the branch of physics which deals with quantum physics and some of the topics which cannot be solved by the classical mechanics. So students perform the experiments in class and they learn how to use the theoretical knowledge, what they have learned in the class, by performing the experiments in real life problems. So they develop various skills such as critical thinking, investigative skills, mathematical problem skills by applying the knowledge to real life problems. What is the entry criteria of the course? So the entry criteria for the course is minimum GCSE grade 6 in physics or double six in science slash additional science with minimum 6 in mathematics with a standard entry requirement of 5 grades 4 to 9. Now mathematics is very important because throughout the course you will deal with rearranging the equations, manipulating two equations to get the third equation, and you will practice mathematics from low level to high level throughout your physics course. So here is the outline of the topics we'll study over the period of 2 years. In year one, we start with module two, where we talk about the physical quantities and units. So this is a very small chapter, and it just deals with the prefixes, the standard form, then 7 fundamental physical quantities and their units. The module three, it's forces and motion. So we have 5 chapters in this module, and basically it deals with the Newtonian mechanics. Now, the chapter motion, forces in action, then we have work, power, and energy, where we talk about what happens when we apply a force on an object and how the work is done. Then we have materials, where we talk about the properties of materials, and then we have Newton's laws of motion and moment. In module 4, which is electrons, waves, and photons, we start with the very basic concept of charge and current, and then we learn how the energy is dissipated and how resistance is calculated from the voltage and current. Then we study electrical circuits, where we learn what happens to the voltage and current if we connect the various components in series or parallel. After that, we study waves, and in waves, we have 2 chapters. We talk about the oscillations of the particles and the energy transfer. We also talk about the Young's double slit experiment, interference, and then we study the harmonics, how they are produced in open-end tubes and closed-end tubes. And the last chapter of year one is quantum physics, where we talk about photoelectric effect and how the photons are removed, how the electrons are removed from the surface of metal, and what is the de Broglie equation, which is used to calculate the momentum of a photon. Now, in year one, you will have 6 internal assessments. First 2 assessments will be done in first 6 weeks of the your First 6 weeks of teaching and rest of the assessments will be done throughout the year. In year 2, we start with module 5, which is Newtonian volt and astrophysics. So again, here we have a combination of different chapters. First two chapters are related to thermal physics. Here we study gas laws, gas equation, states of matter. Then we have circular motion and oscillations. And in this, we talk about what happens to an object when it's moving in a circle. Interestingly, we use the concepts of module 3 in circular motion and oscillations. Then we have gravitational fields, where we talk about what happens to an object when we keep it in the presence of gravitational field of an earth, what happens to the gravitational field of earth when we move away from the surface of earth, and we also learn about the laws of planetary motion. Then in astrophysics, we talk about stars and cosmology. So in stars, we learn how a star is born, different phases of stars, what happens to star at the last stage, and we also talk about the expansion of universe, Big Bang theory, and the evidences which support the expansion of universe. In module 6, we have uh, particle and medical physics. So here we study capacitors, electric fields, electromagnetism, and when we are studying electric field and magnetic field, we also study what happens to the charged particle when we keep the charged particle in the presence of electric field, magnetic field, or in the presence of both. Then we also talk about nuclear physics, and we talk about the fundamental particles, quarks, and how the particles are accelerated, and energy mass balance equation. Then the last chapter is medical imaging. Basically, this chapter is telling us about how the physics is used in medical field. So in medical field, we use X-rays, we use gamma cameras, we use uh, our PET scans and MRI scans, and all these equipments, they are actually using the concepts of physics and the principles of physics. So in year 2, we will have total 5 internal assessments, and there will be one final external assessment. Apart from this, we have 11 practicals which will be performed in year 1 and year 2. Mostly, we perform 6 experiments in year 1 and 5 experiments in year 2. And the practicals are on the spot assessments. They are not controlled assessment. You will separately get pass or fail for the experiments. And in the practical endorsement, there is one research report which you have to produce by choosing the topics from your A levels. So what you can do after your A levels. So A level physics degree is required in engineering, in astronomy, astrophysics, medical physics, aerodynamics, solar and stellar physics, nuclear science. Uh, you can also pursue some other degrees if you have studied A-level physics, and these are material science, earth sciences, natural sciences, environmental sciences, and applied science. So what is unique about our course? So the aim of this course is to encourage learners to develop essential knowledge and understanding of different areas of the subject and how they are related to each other. I just gave you an example in previous slide that in module 3 we'll study about the forces in motion, and they further will be used in circular motion and oscillation. So this kind of relationship between different concepts is also known as synoptic linking. So we also develop the understanding and how to relate different areas of the subject. Then we also develop and demonstrate a deep appreciation of the skills, knowledge, and understanding of scientific methods. So here you are developing various skills such as your numerical solving skills. When you perform the experiments, your teacher is not allowed to help you. You are given a sheet, and then you will research from internet, or you will open your book, and then you will find out how you will perform the experiment. So this technique is actually the investigative approach in the experiments. This is also one of the skill which is very important if you want to pursue research in a higher degree. So, and the most important thing, you are getting ready for the university here in A level. So you will develop interest in various areas of the physics, and it will give you an idea which career is most appropriate for you if you want to pursue higher course. And the important part of this course is you learn how we are relating the concepts of physics to the real life problem. And that is the important part when we study any science subject. We learn how this particular science subject is actually contributing to the society and how it is actually contributing to the success of the economy. So this is very important in physics, how science works. So we are also understanding how different concepts we are learning, they are helpful in the development of the society. So my couple of my students, they have shared their experiences studying A-level physics. One of my student, Calend, currently he is pursuing physics degree in UCL, and one of my student, Alex Pine, he is pursuing natural sciences degree in Greenwich University. So for example, Alex has written that he developed the technique of manipulating graphs by using calculus as a tool to find concealed values. For example, in simple harmonic motion, where I used a graph of displacement against acceleration and differentiated the line to obtain angular frequency squared. So this has improved my ability to keep things simple by confidently using dimensional analysis with various units to give a simple base unit. I have used calculus thoroughly during my degree in chemistry when analyzing my results from the laboratories. Moreover, when becoming an online tutor at Tutorful, I have taught it to my students. So this is just one example from how particular topic has helped Alex developing his skills and how those skills are actually helping him further in his higher degree or in his online tutoring. So student life in Hastings College is very exciting. Hastings is a quite big campus with equipped labs, and we treat students as adults. You are encouraged to undertake independent learning, and teachers provide help, support, guide throughout the course. You have ample opportunities to interact with your peers, with your teachers. Uh, there are additional costs. Your textbook, so I teach OCR specification for physics, and the cost of the book is approximately £43. Then a scientific calculator. This is a particular calculator. If you are choosing mathematics, then you have to buy a Casio 991EX calculator, and which costs £26. Otherwise, any simple scientific calculator would be fine. You can buy books online. When should you buy the books? You should pay it for first half term. I'll let you know during the first half term when you have to buy the book. So do not buy a book beforehand. I will let you know during the course. If you need any help, financial help, then the bursaries are available, and you have to check with finance office during the enrollment for the bursaries. So now we are switching to live question and answer section. Uh, I'm stopping the screen sharing, and you can ask the questions. Okay, so here is a question from Eileen. What kind of experiments do we get to do? So it depends upon the topic we are studying. For example, in module 3 we perform a viscosity experiment, and then in module 4 where we have these electricity experiments, you can just connect any component in a circuit, and you can study VI characteristics. In year two, we study a Boyle's law experiment. So there are various experiments we perform in the A levels. Most of the students, they can join either physics degree in university, or they can join engineering degree. They can also join medical physics degree. So it depends upon what is the combination of the subjects you are studying. Thank you for the question, Serena. So here we have a question from Craig. Do you offer degree level courses after the A level physics? Unfortunately, we don't have any degree level course in physics, but there are some courses in HE for which you have to check with the HE degree courses site. What are other good subjects to pair with physics? Uh, Maths and chemistry, they go well with physics. If you are aspiring for biophysics, then biology also a very good combination for physics. And sometimes students study history, maths, and physics. So it depends upon what kind of subject you want to study in a higher level university. So thank you very much for attending the presentation. We are wrapping up now as I'm running out of time. So if you have any question, you can drop your question on college website, or you can directly email to my email ID. Thank you very much for attending the session. Bye-bye.